Assalamu alaikum. How are you, grade 4? Today our lesson is characteristics of sound waves. Sound is a type of energy, so we cannot see the sound waves, but we can represent the sound waves. Let's do this experiment. We need for this experiment rice, plate, and speaker, source of speaker. Now what I will do, I will put the rice above of the speaker, and we have to observe what will happen to the rice particles. Now the speaker will produce the sound energy. This sound energy will transfer to the rice. Remember the energy of sound. Let's open the speaker. Are you ready? Did you observe? Again. If you observed that the particles of rice don't change their place, it's only vibrate back and forth or up and down, not moving from their place to another place. Why? Because the energy only move, not the particles of rice.
Sound is basically vibrations, and we can represent sound using special diagrams that are kind of shaped like a mountain and a valley. And because these diagrams are shaped a little bit like mountains and valleys, we describe them as waves. Waves. I don't get it. We've all got a basic understanding of what sound is because we hear things every day. And we've probably got some idea of how we might describe some of those sounds. A good place to start is how loudspeakers work. Basically, when a loudspeaker is going to generate sound, what it has to do is move up slightly and then back down. And it's going to do this really, really fast in a little pulse. Now, as the loudspeaker does this, the air molecules that are immediately in front of the loudspeaker will be forced outwards. And those air molecules are going to collide with the next set of air molecules that are right in front of them. And then those air molecules are going to collide with the next ones in front of them, eventually transferring this little pulse away from the speaker. Now, this alone is not enough to create sound. In order for sound to be generated, this pulse has to happen repeatedly. It has to happen many times each second. The vibration of air molecules allows sound to travel at a speed of 340 meters per second. Now that sounds quite fast, but if we compare it to water, which is much more dense, meaning the molecules are much more close together, it is capable of transferring sound at a faster speed of around about 1500 meters per second. Now let's look at this diagram of air molecules vibrating as a consequence of this pulsing of a speaker. What we've presented here is something called a longitudinal wave, but it's a little bit more convenient to present sound diagrammatically using something called a transverse wave. On this diagram, we can see from the transverse waves that there are 3 waves within a time frame of 1 second. This means that the speaker is vibrating at a rate of 3 pulses per second.
Now, what is the difference between these 3 types of sound? Girl's whistle, and the bird, and the recorder, or this machine. Sound is a type of energy, which is kinetic energy. Sound is produced by moving particles of matter. If you remember, this we call it longitudinal waves, or if you can observe parallel. And this type of waves, we call it transverse waves. If you can observe, it's perpendicular. So, the compression here, we call it peak. And the rarefaction here, we call it dip. Now, every wave made of one peak and one dip, or one compression and rarefaction. Sound wave properties. Today we start with these three properties of the sound waves: wavelength, frequency, and pitch. Let's start. First one, wavelength, is the distance from one rarefaction to the next, or from one compression to the next, or the distance from one peak to the next peak, or the distance from one dip to the next dip. We have to measure it, by the way, to find the wavelength. Question: could you measure the wavelength of the following? So please use your ruler and measure. Are you ready? First one, the wavelength is 2 centimeter. We call that short wavelength. Second one, the wavelength is 4 centimeter. We call that long wavelength. Can you see the difference? Here shorter than this one, and this one longer than this one. Second one, frequency, is the number of vibrations or waves of sound per unit time, and all the time we use second. So if you can observe these pictures, here if you count the waves, 1, 2, 3, 4, 5, 6, so almost 6 waves. We call that high frequency. So if you observe, here sound waves have peaks close together, and we call that short wavelength. So this is high frequency. Second one, 2 waves. Sound waves have peaks further apart and longer wavelength than the other. So we call that low frequency. So all the time, to identify frequency, we have to say low frequency or high frequency. Question: what is the wavelength of these waves in the pictures, and what is the frequency? So please send to me. Yes, I will wait. So send me the answer. Third one, pitch. Pitch is how we hear the frequency of a sound wave. So pitch depends on frequency. If we have here, if you can see the sound of this bird, if you can see shorter wavelength than the other and high frequency, so it's high pitch. Also this one, high frequency, high pitch. Second one, the sound of lion is low pitch, low frequency, and low pitch. Also these, longer wavelength, lower frequency, lower pitch. Shorter wavelength, high frequency, higher pitch. Homework: compare between the 3 instruments: wavelength, frequency, and pitch. Now, I have my piano. Let's practice. And I will show you the link to practice at your home. Now, this one. This is high pitch or low pitch? Yes, low pitch. And this one. Yeah, this is high pitch. Now, another one. You have now to recognize this is high frequency or low frequency. Ready? What? Yes, high frequency. Now this. Yes, low frequency. Another one. Now, you cannot measure the wavelength, but let's try. Yeah, it's difficult. Let's summarize. So today we studied about 3 properties of sound waves. Wavelength is the distance from one peak to the next peak, or the distance from one dip to the next dip. Frequency is the number of vibrations or waves of sound per second. Pitch is how we hear the frequency of a sound wave. Thank you. See you next lesson.